So very good evening to all. There is some technical issues, so no problem. So let us start today's session. So if you have Matlab, then you can side by side you can go on. No issue. Everything will be recorded. So I will send the recorded my today's presentation in my YouTube channel. Even you can get into my YouTube channel. You can even subscribe so that you will get updates of any details with respect to academic aspect. Okay, so let us start. So I will share my screen. So you can just even message me, it is okay, that are you able to view my screen? Even just if you message, it is okay, then so that I can proceed further. Okay, thank you. So on behalf of S.VINOD University, so it is my pleasure to give a session on modeling of converters and inverter for solar PV application. So myself, I am Dr. S.VINOD. I am working as an associate professor in the Department of Electrical and Electronics Engineering at Jerusalem College of Engineering. So we will see in the introduction to Matlab, then followed by what is a solar cell. So today we will see about what is solar cell, then what about solar panel, then what is the solar cell in Matlab available, then we will see how to model a solar panel. So combination of cells makes panel, then testing of solar panel using Matlab. Testing is for various value of your load, what is V and I, then power and current and all. Okay, then we will see from the solar panel output I have to give to a boost converter for boosting up. So there I have to boost from the voltage to the required voltage. Then I will put an inverter and show you. Inverter I will show with normal inverter and then Sine PWM inverter. So this is what we will see today. So Matlab is nothing but a matrix laboratory. Everything what you give it to Matlab will be converted into matrix, and I try to solve. It will try to solve all like mathematics, algorithm development, then data analysis can be done, exploration, visualization can be done, then scientific and engineering graphics can be done. Application development include graphical user interface building is also possible. So now let us move on to solar cell. Mainly there are three types of solar cell available all over the world. First one we call it as monocrystalline, made up of single type of material. Okay, then comes polycrystalline. So this is basically made from wastage of manufacturing of monocrystalline. So at the time of manufacturing of monocrystalline panels, there may be some wastages, and that is being melted and tried to form as a polycrystalline. So here you will have 3 or 4 types of material being used. Then comes your thin film. So among this, monocrystalline is high efficient compared to other two, and when you see rate, since any person who has more efficient will be more of cost when compared to other two. So this is about a solar cell. So solar cell, each solar cell will have a open circuit voltage of 0.6 and a short circuit current of 5.92, which means if you are not giving any load and if you measure the voltage, what is the voltage measured, we call it as open circuit voltage, which means I have not connected any load. Similarly, short circuit current is nothing but a mere short between the two terminal, try to see what is the maximum current. Okay, so both these two cannot be used, both your open circuit voltage and short circuit you cannot use. Okay, and then irradiation is nothing but what is going to fall on the solar panel. So we should be very clear, heat energy or light energy is not converted into electrical power from the sun, only photons. Okay, only if the photon hits on the solar panel, it's get converted, and when you see the sun, it is of yellow in color, which indicates it is sodium present in the sun. The wavelength of sodium is 1000 watts per meter square. Okay. Now how you make solar panel? So just take the solar cell, connect it in series. You can see in this diagram very clearly. First cell is connected in series with second cell, third cell, and then it is being continued in a series fashion, and finally one terminal is positive, another terminal is negative. Approximately you take 100 watts solar panel. There are nowadays 100 watts, 150 watts, 200, even 300 watts panels are available. So now let us think of an 100 watts panel. So for an 100 watts panel, you require an operating voltage of 12 volt. There is a difference between operating voltage and open circuit voltage. Okay, so here we take polycrystalline. So maximum voltage at maximum power, which is 18.2, and the current at maximum power, which this 2 is nothing but if full sunlight falls on the panel. Okay, then comes open circuit voltage. I have already told open circuit voltage is nothing but connecting without any load, just keeping your multimeter between the positive and negative. That is open circuit voltage. But if you give any voltage, automatically your potential will fall. Similarly, short circuit current, which means load doesn't have any resistance 0, and again that condition is also not possible. So in order to generate this 100 watts panel with an output operating voltage of 12 volt, you require 36 cells. You can see here we have connected 36 cells in series. The weight will be approximately 7 kg. Okay. So now how you want to do this in Matlab is, first when you double click on the Matlab icon on your desktop, this screen will pop up. This screen has a space called command window, a space called workspace. Okay. So in this, what you have to do is click on the new button. A pop-up screen will be there. There you can see Simulink model. So when you press the Simulink model, automatically a new screen will get opened. This screen is where we are going to do all type of simulation. Initially it will be untitled. After, if you do something, you have to save it. Now to start up, you should know something called Simulink. Okay, how you got this is, here you can see a 4 box with one in blue and one in red and another 2 in white. So this is called a library browser. So once you click that library browser, this screen will pop up. Here you can see Simulink. There are so many components present in Simulink. Okay, then you will use Simscape. Just take down as an ins. Only 2 block set we will use. One is Simulink block set, another one is Simscape block set. So only this 2 block set we will use. Other block set we will not use for simulation of solar panel, converters and inverters and all. So now you can take down various blocks required for simulation of solar panel. Or you need a solar cell. Then you need, see, this solar cell is not available in Simulink, it is available in Simscape. So I have already told Matlab is matrix laboratory. So in a matrix laboratory, 2 Simulink cannot be directly used, because 2 Simulink will separately be solved with a separate solver. So to club it, I use any issue. Shall I proceed?
Sir.
So here we have a conversion from PS to S. Then this is for voltage measurement. This is for product. Then this is solar configuration. Then constant. You need a ramp and you need a variable load. Then similar to PS to S, you required S to PS. Then current sensor. Similar to voltage sensor, you need a current sensor. This is, we call it as XY graph, and this we call it as control voltage source. So when you click on solar cell, these all will pop up. So now let us take a short break from this and let us move on to Matlab and see where all these components are there. Okay. So what I have told you, have to go and press here. So automatically a screen will pop up, and that screen we call it as your Simulink library. Okay, please wait, it will take some time since I have already opened so many Matlab files. So this is, I have told no, there is two
Sir,
blocks.
once again, sir.
Ma'am?
Sir, if you're going to do in slow, or கொஞ்ச நேரம் sir, பசங்க turn on பண்ணிட்டு இருக்காங்க. ஓகேங்களா, நீங்க சிம்லிங்க் எப்படி போறதுன்னு இன்னொரு வாட்டி சொன்னீங்கன்னா உங்களுக்கு யூஸ்ஃபுல்லா இருக்கும் சார்.
சரிங்க மேம், நோ இஷ்யூ, நோ இஷ்யூ.
நீங்க அடுத்து உள்ள போயிட்டீங்க.
I will show it in PPT ma'am, so that
Matlab எப்படி போறதுல இருந்து ஸ்டார்ட் பண்ணுங்க சார்.
Okay. See, just you can go
okay,
here.
Sir, one second.
In your search column, just type Matlab. So this is that Matlab. Just click on this, you will get a pop-up screen which gets opened up, and this is the screen which gets opened. So are you getting this particular screen?
Yes sir.
If this is okay, then you have to go to this new, create a new document. You have to go to this new. In this new, you have to go to this Simulink model. Okay, just click on this Simulink model. This particular screen will get open. Always I have told no, it will be untitled, name will be untitled. Unless you save, it will be untitled. Just press this and you try to maximize it. Now what I have told is you have to press this library browser. So once you press that library browser, the screen will get popped up, and this is where we are going to pick and drop each and every component which is required. Okay, so now I have already told no, to simulate your solar panel block diagram, all this is required. So just what I am saying is, just go to that library browser, just type here. So it will be easy for you, solar cell. Just type it and press enter. We know where it is directly available, but for as a fresher, this is easy way. Just in the search column, you press solar cell. So here you are able to get this solar cell. Just right click on it. See, just I am right clicking on it and then say add to untitled one. Add to untitled one. So automatically this will be added in this particular screen. Are you able to do this? Are you able to pick up a solar cell?
Yes sir. Yes sir. Yes sir.
So in this, even I think it will be more convenient if I come directly to the college also. Even I should not see about the traveling distance. So here you can see this is solar cell. So just if you double click on the solar cell, so this is will be the popping out. Then when you press it, here you can see it is given open circuit voltage 0.6, short circuit current is 7.34. all this you can change. If you are downloading some from data sheet from some site for 100 kilowatts or 100 watts, and if I want to change the current, that depends upon the configuration of the solar panel. So even you can keep it as 6 amps or 5.5 amps or 6.5 amps, whatever you want. Just go in net, try to see what is they are showing. From there you can do it. So now what I have done is I have taken a single cell. So to make it as a solar panel, see, just click right, place your mouse on the solar cell, just right click and then drag. So you will get one more. Just I will repeat it. Just press right click and then drag. So this way you can take. So now to make a solar panel of 36 cells, what I am doing is just repeatedly I am copying. So now it is 5 times I have done, one more time you can do, and this is a 6. So but what I have required is 36 cells. See, you can see here I am connecting in series. One output of the solar cell I am connecting it to another. Okay, so like in this fashion I repeatedly connecting the solar cell. So now I have connected 6. Now what you can do is just left click, then select all. Now press right click and drag. You will get automatically the required 6. So now 4, 5, 6. So now 36 cells I have arranged. Now what you have to do is you have to connect it in series. No, so from here you have to take it to the top and connect it. Okay, take it to the top and connect it to here. So now you can see here you have one terminal, and at this end you have one terminal. Now the next thing is, here you see a small box. This is nothing but input to the solar cell. The input to the solar cell is nothing but irradiation. So how to connect this irradiation is, so you can see here, no, I have connected all irradiation and taken from one module. Similarly, from all the modules have the same block. So you can ask me how to make this block set. It is so simple. You can see here you have drawn, no, like this. Then just left click and try to select all. Okay, but now what you have to do is, before making it as a small block, you have to connect all this. Okay, for me no issue. Even if you want me to take for 5 hours also, there is no issue. Only there is time concern with respect to you, because you have to travel back. So I will try to show something by doing now, and something I have already done, so that from that you can also view it. Even if you want elaborately, then no problem. You can arrange some other day also. I can even teach you, that is not an issue. But now just how to make subsystem I will tell you, because before connecting subsystem, what we should do is we should connect all this terminal, because all solar cells receive same amount of radiation, so from the sun. So all the radiations of the solar cells are connected. Okay, the input for all the solar cell is same. So here you can see I am just connecting all the inputs for the solar cell. These are the inputs. So there is only one input for solar panel, that is nothing but irradiation from the sun. Irradiation from the sun is nothing but the photons which is falling on the solar panel. So just it takes 2 or 3 minutes. I will connect it and then show you. Even till this part is also okay. This part also you can delete it, just to understand only, no. So now you can see here, this is one terminal, this is another terminal, then one terminal which is I have kept it is for connecting photon. Just left click the entire thing and then press right click, and there is an option called create a subsystem. Just click on it, you will get like this, 2 output and 1 input. So this is for irradiation, and this 2 is 1 positive, 1 is negative. So like this only we have done it, and we have combined it, and we have formed it as a module like this. So you can see here irradiation plus minus. Again, see inside this only 6 cells is there. So 6 I have connected and made it as a, each 6 I have made it as a subsystem. I repeat, each and every 6 cells is made as a subsystem here. So I am just clicking on this, I am able to see 6 cells. So this 6 cell is connected to the input, negative is connected to positive of the second, and repeatedly I am going, and then finally you can see that one input is radiation and one output is positive of your solar panel, another one is negative of the solar panel. Now what is our next step is, so this is what the solar panel is. So inside this box only till now we have seen. I will again show you how to go into this is, just go to mask, then look under mask. So this screen will open. Here you can see one is radiation, 2 outputs are there, one is negative and one more is positive. So now the thing again you have to notice, all this thing is made from Simscape. Okay, solar cell block was available in Simscape. So in Simscape under source you have this solar cell. Now this Simscape, when you want to connect it with the Simulink, there you need a conversion block. So what I am connecting is, I am going to give radiation. Radiation is nothing but from sun. Whereas this block is, this block is called as a constant block. So in commonly used to block set, there is a block called constant. So this constant. So only this block I have taken, but just I have, whatever I want I can write. See here, I will show you. Just if you say add it, this will get added here. So it is added here. So here underneath I can write whatever I want. So just for our understanding, I have written it as irradiation. Okay, irradiation and all such things I have written. So like that you can do. And if you are not giving any value, the value will be 1. But if you want to make it any value, just go inside, double click on it, and it will, a screen will pop up. There if you enter, it will become that corresponding value. So that I have done here. Okay, you can see here radiation. So now I am connecting radiation as an input. So this can be maximum of 1000. I have just given as 900 as an input. The only thing you have to remember is this is positive and this is negative from the solar panel. On the negative of the solar panel, you have to connect one ground and you have to connect Simulink configuration. I will show where it is. So it will be useful for you. That is called a solver. So just go and type here solver. You get various solver, and the solver which we want is Simscape solver. So in Simscape there is a person called solver. Just how to add is, just right click on it and say add to module. So it will get added. So that is being added here, and it is connected to the negative of the output. Okay, and I have connected one ground here. So this block is a ground block. So now what I have did is, I have prepared the solar panel, I have given input to the solar panel, then I have taken output of the solar panel, and two things I am connecting. One is ground, another one is this solver. Now the next step is, I have to measure current and voltage. Current will be measured always in series, and this block is called current sensor. Just in Simulink, same browser, press CURRENT current sensor, and if you press enter, it will be available in Simscape. Okay, so in Simscape there is current sensor. Just right click it and add it here. So I have added here. Similarly, I have to add voltage sensor. See, current should be always measured in series, so I have put a series to the resistor, and this is called variable load. See, the step is, you want to test the solar panel. How you will test? Bring the solar panel, keep under the sun, then you constantly vary the resistance. Keep the resistance at 0, then you will get maximum current. Then go on, increase your resistance, current will decrease. Simultaneously current will decrease and voltage will increase. And when you plot between this voltage and current, you will see at what maximum voltage and current I am able to get from that particular panel. only that is called as operating voltage or the operating point. Now to identify the operating point only we are doing this part of simulation. So now again I will tell you, this block I have variable load I have taken outside from this is taken from Simscape. So to give an input for the Simscape load, what I have told, resistance should be varied from 0 to maximum. This is called ramp. Ramp will be initially 0 and finally it will reach 1. So that block I have connected. Now again this current sensor output and voltage sensor output are in Simlink. To convert this Simlink block into Simscape block into Simlink, I will use PS to S. That is from Simscape to Simlink block. Then what I am getting is current here. What I am getting is here is voltage. So whatever you want you can measure. One is I am going to measure V versus I. You can see here this is called scope and this is called XY graph. So where this is available is, you can come to Simulink. In Simulink you call it as sync. In sync you have this XY graph and this scope. So this XY graph I have taken here, so which will have two inputs. I can give one input voltage and one input current, and this is called scope, will have only one input to receive. Scopes are like similar to your CRO. So scopes are like similar to your CRO. Now one thing is, here I am measuring V versus I. Similarly P versus V, power versus voltage. So how to get power in DC? Power is nothing but V into I. So just multiply V and I, you will get power. To do this, what we will do is, in Simulink there is a called product. Product is nothing but multiplying both. So that is there in Simulink. In commonly used block set there is a person called product. So from here you have to pick that product and then you have to place it here. So now I think we are connected all the components here. So I repeat, from the solar cell I am connected voltage, current sensor and voltage sensor. Voltage sensor in parallel, current sensor in series with your load. And this is not the normal load. Load with the zero resistance initially and finally reaches the maximum resistance. So this is called variable load. This is connected with a ramp, so that initially it will be kept in 0 and finally it will be kept in maximum. So you measure now, current and voltage are measured. So from that I will, in one graph I will see V versus I, in another graph I will see power versus V. So after connecting all this, what you have to do is just press this green button. So when you press this green button, it will start simulating. Initially it will compile your circuit. While compiling, it will check whether all the connections are properly given. So it takes some time for compiling. So once it gets compiled, it will start running. So when you use this XY graph, there is no need to open and see. Automatically this graph will automatically pop up. Once the simulation starts, this green will pop up, and once this screen pop up, you can see that this is power versus V. So power of this solar panel is around 300 watts and the voltage at this 300 watts is around 40, nearly 40 volts. And similarly this graph shows what is the value for selecting R, resistance. So you can see here at the value of 40 volts you have approximately the maximum current. Okay, 6 is the current we have set it. So when this is the region where you can operate. Here you are not supposed to operate, or here you are not supposed to operate. So operate only here. So maximum voltage and maximum current. So this point we have identified. From that we can calculate the R. R is nothing but V is equal to IR. So V divided by I will tell you R. So here you have I, you have V. From there you can measure and then put that particular value in your circuit. And if you simulate it, you will get the voltage and current waveform. So this is how the first step of our today's session is. So we have seen what is the various blocks available, and then we have seen about how to arrange it. So once you arrange it, then how you connect it, then we will see about what is the voltage versus current here this is voltage and this is current. The circuit which I am showing is 300 watts, but the simulation circuit which is shown in the slide is for 100 watts. Okay, so there is some variation. The slide what we are showing is for 100 watts we have done, and but the simulation file which I am showing today is for 300 watts. Okay, so this is for 100 watts, so voltage is around 20. Beyond 20, if you go, current starts to decrease. Then this is the power. So I told no, the PPT circuit diagram what we have done simulation is for 100 watts. So maximum is 100 watts, beyond which your wattage starts to reduce. Okay, and this is the power versus V. So for maximum power, for which you get what is the maximum voltage. So from this we will calculate R, and that can be the maximum load that can be connected. So now the thing is, the output of the solar panel will not be the required voltage, it will be around 92 to 96 or 98 volts. So from there I want to convert it into the required voltage. For us is AC unit 230 RMS, but the peak is 230 into root 2. So 230 into root 2 is nothing but 326 volts. So how to get this 326 volts from your output of the solar panel? The step is you have to go for a boost converter. So what is a boost converter? So if you connect an input source here, at the output voltage will be boosted, which means if you give input around 100 volts, it will be boosted to the required volts. So here what we are doing is, we have fixed the input voltage as 96 and the output voltage we try to get it is 480 volts when the duty cycle is 0.2. Okay, now when you see this boost converter, you should know how you are able to boost. So that is with the help of this particular switch. Yes, okay, so you see here you have a voltage, in series you have an inductor, in series you have a switch. So this is one path, and the next path is from the switch, this diode, from this source, this inductor, this diode and this capacitor. Now what happens is, this switch is fired at very high frequency. So when the switch is on, what will happen? The source will charge the inductor to its maximum value. No current will flow in this path because the switch is closed. This is the least resistance path. So current will take this particular direction. So current will start here, it will try to get charged this inductor and the path will get closed. Now when you open it, now this voltage plus charge stored in this voltage will try to travel to this diode and will charge this capacitance. So if this is V, this is 2 times the V, the capacitor gets charged. So capacitor try to discharge to the load with the twice the value of the input. But the thing is, capacitor is not a source, you will discharge at very faster rate. So what you have to do is, your processes also should be at very faster rate. So that is why we say converters are operated at very high frequency. So at very high frequency you charge and discharge at very faster rate, so that your output does not touch 0. Your output does not touches 0. So this capacitor discharge is possible only if you operate this fellow at very high frequency. Okay, so next slide we will see about what is V out divided by V in is equal to 1 divided by 1 minus D. So this is the relation between input voltage and output voltage with respect to duty cycle. Duty cycle is nothing but your T on and T off. So when you substitute your D, say let us assume I am turning and turning off at a 0.2%, which means 1 divided by 1 minus 0.2, which is 0.8. So V out is equal to 0.8 times of V in. So when you multiply it, you can see here it will be around 480 volts when you are giving your input to your converter. So similar to your solar cell, we will see what and all component required for simulation of a boost converter. So to do a simulation of boost converter, you require DC voltage source then you required a MOSFET, then voltage measurement block, then RLC branch, then comes RLC load, then scope, then current measurement, pulse generator and a diode. Now I will show you. So now let us move on here. I will show from where I will take all these things. Okay. So simulation of a solar panel is alone tedious, but simulation of boost converter and all is very easy. So I will take one by one. So first, what and all you have to take? So you have to take a DC voltage source. So go to this library. Here in your Simscape, go to Simscape. So in Simscape you will have so many sources. So you go for electrical sources. Okay. You have all type of sources are there. Now I want a DC source. For that, what I will do is I will go to this utility. So specialized technology I will go. So in this specialized technology, just take down this alone. If you have any scribbling paper, so just take note of it. In Simscape, under Sim Power System, I am going for specialized technology. So in this specialized technology, there is so many blocks. Here you have electrical source, here you have DC source, you have battery source and all. Here you have DC voltage source. Just right click and just press add to Untitled. So automatically source will come into picture. Next step, what you want, I have taken source, then I have to take MOSFET. So similarly, how I will take MOSFET is, so here if you see power electronics is there. In power electronics you have all the device. Same way, just right click, say add to Untitled. So automatically MOSFET will also come here. So we have taken two fellows. Now I want inductor. So for inductor, so if you see in elements, so you will have RLC branch and RLC load. Just click on RLC branch, it will get selected. Now what I have told is three fellows are in. So how I did is just Control R, just press on it, and then if you press Control R, it will rotate. Just I have rotated it. Here I want only inductor, so I will take this, just place it here, double click on it, it shows RLC, you just press it as L. Okay, so now you will get L. Now what is the step is, from DC source you connect this L, similarly from this you connect to this, and then close this path from the DC source to here. So you have connected. Now the second step is, in our circuit we have to see your circuit and then connect. So I have taken DC source, I have taken inductor, I have taken switch. Next is one diode and one capacitor. So where is diode is, again you come to this power electronics. In power electronics you can see this diode, just add this diode. Again I want one capacitor. For that, go to element, then go to RLC branch, add to it. So now you can see you have received both this. Now just connect this diode here. Similar way, I will press Control R, it will rotate, then double click on it. You have RLC, now you make it as C. That's all. Apply. You will get this here. So now our remaining part is what our circuit required is. So I have connected as DC source, an inductor, a MOSFET, a diode, then a capacitor, and this is RLC load. Then I have to measure what is this load draws, I have to connect current measurement. Okay, so this is already simulated circuit I have. Till connection we will do, then we will see the output from that particular portion. Now this is the load I have taken. Now I have to take V measurement. So same, go to this measurement. See, all the things are available for simulating a boost converter. Everything is available inside specialized technology. So now you want two fellow. One is current measurement, another one is voltage measurement. Just press right click, you will get it. So current, voltage there is no issue, but current should be connected in series. So in series I am connecting it. I am right, so I have connected. Now again load should be connected here, so connect the load here. Now it is how you will measure voltage. Voltage will be always measured in parallel. So connect, there are two terminals, you can connect it. See, if possible we will try to have direct interaction. The only thing is travel and all such things. Your management is also ready and myself is ready, but the only thing is how to arrange it. We will see whether if possible we will in person also we will meet. Now next thing is, from this current measurement and voltage measurement, I should connect to the scope. Scope is only available in Simulink. So come to sync and directly add. So now we are able to take scope. Just connect the scope to your current measurement and to your voltage measurement. So all the connections are given. Only thing is you have taken a MOSFET, but how you are going to fire this? You can see here there is an inward arrow showing gate. That is nothing but how you are going to give pulse. So to give pulse, you come to Simulink. In Simulink you will have something called source. In that source you will have one thing called as pulse generator. Just take it. So this pulse generator block you have to take it and give it to your MOSFET. So till this we have connected all. So I think we are ready to do simulation for boost converter, but some values have to be entered, no? So that I will take to my circuit where I have already entered and kept it. So voltage what I am keeping is input. Just double click on it, this will pop up. I have already told, no, we have to give 96 volt as an input. I have given 96 volt here. Then this is the pulse generator block. So in pulse generator block, what and all you have to give is what is the frequency in which you are going to operate your MOSFET. So the frequency of operation of MOSFET is, I am giving in terms of seconds, or even you can give it as 1 divided by 25,000 also you can write. So 1 divided by 25, how you will write? Just put 1 divided by slash symbol, then 25,000. This way also you can write, or you can write it 0.0004. Okay. Then you have to give one pulse width. The maximum pulse width, your voltage will be minimum boosted. So if you want to go on reduce your pulse width, we will see what is happening. Then delay is not required because you are going to use only one switch. Okay. Then all this inductor value I have kept it as 10 millihenry, and similarly capacitance as 1500 microfarad, and this load we have given it as a nominal voltage of 100, frequency of 60, or you can just take this load and keep it, there is no issue. Now we will start our simulation. I have already told, press this run button. So once you press this run button, your simulation will start. See, you can see here time is running. It has been asked to simulate for 10 seconds. If you want to get the result earlier, just make it as 2 seconds. So you have to wait. So it is around 0.05% as been simulation is carried out. Even now if you go and see, you can see the voltage. Okay, I will just stop running the simulation. Then I will go inside this voltage and I will try to press this auto scale block. So if you plus this auto scale block into 10 power 23 is showing, so which is around 300 to 400 volts. Now when you vary this duty cycle, obviously your output voltage will vary. So let us simulate for so now it is doing its simulation part. We will see. Let us wait for 0.5 seconds. Initially you are not supposed to stop and see, then you will see only the transient part. You will not see the steady state part. To see the steady state part, at least you have to run for some short duration. Okay, so let it be running. We will move on to the next part of today's session. So then we will come back, because why we want to waste time, rather we can use the next aspect. So here you can see that I have simulated it, the same circuit. So here you can see your output voltage is around 400 volts and input voltage is around 100 for various duty cycles. So if I keep the duty cycle at less than 15, 50, 60, 70, 75, 80, so when I am gradually increasing my duty cycle, my output voltage is increasing. What is the next step? Next step, see, we have completed what and all we have completed. We have completed a solar panel. So the output of the solar panel is given to your boost converter. So you can interconnect your output of the solar panel to the boost converter. The next step is you have to interconnect this boost converter, output of your boost converter with respect to input. The next step is you have to connect it to an inverter and get an AC output. Okay, AC output only we can use for our applications. So because most of the applications required AC supply, so to get AC supply you have to convert this DC into AC. So here you can see this is the basic circuit diagram of an inverter. So you will give AC to this terminal ends, and at this intermediate point you will tap it, you get AC. See, for example, the switch G1 and G2 will be operated for positive of cycle, and G3 and G4 will be operated for negative of cycle. See, if I give a firing pulse initially to this circuit, then after 10 milliseconds if I turn off this and try to turn on this circuit, then automatically initial part current will flow in this direction, and during the second part current will flow in this direction. So your input DC will be converted into AC. So this is the same circuit I have drawn with the help of the Matlab. Okay, I will show you. So I will show you directly to a Sine PWM, how to do Sine PWM, because square wave and all we will not use. We require only Sine PWM. Okay, this is normal square wave AC waveform output. So rather we require a sine waveform. So for sine waveform, what we will take a reference sine that you will try to compare with the triangle. So your pulse width gradually will increase and reaches maximum, and then it will gradually reduce. Okay, for this we can do our simulation. I will say how to do it, and this will be the output of the sine waveform. You can see here initially the output width is very less, the width gradually increases. Here you can see at maximum width, and again it starts to reduce. So this is positive of cycle, and this part is called negative of cycle. So positive of cycle of the output, you get it as if like slowly it is increasing and gradually reaches maximum width, and then again it starts to decrease. Similar way in negative direction also we were able to get it. So this is the final required output. So this output you will give it to the load, like whatever AC loads you want. So our end of today's session is, you have seen a solar panel, boost converter, and followed by inverter. So this is without any battery setup. So there are some places like you are going to work from morning 10 to afternoon 2, during that part of time, or till 3 or even 4, in Chennai or in Tamil Nadu and all, you can get even till 4 o'clock your solar output. So any government buildings starting from morning 10 to evening 4, their power from the solar can be directly used. You don't want to go for any batteries. Similarly, you can even connect it to grid also. So whatever you generate, you pump. You no need to put install batteries. Install battery is another issue. Battery has to be maintained, or every 2 years you have to replace the battery. Rather, what you will do is, their government is certifying an inverter. That inverter, what it will do is, it will get the DC power, boost it, convert into AC, feed to the line. If you are using, you will use, otherwise it will be fed back to EB. That we call it as reverse metering and all. So you can now you can connect your solar panel with the boost converter with the inverter. So now even I will show you the inverter circuit. I have already kept it simulated and kept it. I will show what and all blocks required. So for an inverter you required 4 MOSFETs or IGBT. IGBT is also available here. So you go to Simscape. I have shown you now in under Sim power system. You have to go to specialized technology. There you have a person called power electronics. There you have all type of devices. Even IGBT is available there. From here I have taken this IGBT and placed it here. Okay. So 4 IGBTs I have placed, and for the snubber purpose I am connecting diode opposite to the direction of IGBT. Okay. If the current is going to flow in this direction in IGBT, diode is connected in opposite direction. This is nothing but RLC branch. In RLC branch I have taken R alone. Then this is voltage measurement block I have given to scope. So this is the input DC voltage. Now after the boost converter, it will be around 312 or 315 or 325. So that value I have given here. That's all. Or if you interconnect your circuit, then no need for separate DC source. Okay. So 4 switches I have connected. Now all these 4 switches has to be given some firing pulse. No. So we will see how this firing pulse are generated. So there is a block called a signal generator. Where you have to go to same Simlink, come back to Simlink. In Simlink you have called a source. In that source you have a signal generator. You can see here, it has been touched. So here you can see here signal generator. So take that signal generator block. Inside you have to write it as sine waveform. So there are so many types. Is there sine square, sawtooth, random? So you take sine. I am just giving amplitude as 0.97. Then frequency is 50. So I have generated a sine waveform. For positive half cycle I am directly going to use. For negative half cycle I will multiply with -1. So it is like shifting. Okay. Now taking this positive half cycle, what I am going to do is, see, this is the sine which is coming. I have to compare it with this fellow called ramp. So once if I compare with this fellow, then automatically I will get sine waveform output. So I will simulate it and I will show you. See, just press this simulation button. This is older version of file. So it asks for open upgrade advisor. So just click on that open advisor. So it will initialize and it will do all the updation, because it is just lower version of this file. I have long back simulated this, more than 5 years back. So now latest version of Matlab, you have to initialize before using it. So it is initializing, but if you try to take it and put the block, and that will not happen. If you are doing in the same version itself, then it will not happen. This only the file. This file I have long back I have done simulation. So you have to wait for me just for 2 minutes. Then I have to run the selected chart. Checks, so it will run it. Once it run, then it gets adapted. That old file will get adapted with the new file. Then it will start. You can start simulating and try to view it. that's all. So now it has been combined here. Now one thing I will show you, just I will take this block inside and I will show you. Control C. So here you can even understand it better. Even you might have studied what is called Sine PWM and all, but you will understand when you see the simulation files. Just right click on it, go to mask and go to look under mask. So this is that present inside. Now what I am going to do is, this is one input, this is another input, and we will see, we will take one more input from the scope. So how to include all this thing is, you just go to scope history, there it will say the number of axes, just make it as 2. So here I am going to connect it to my output. So this is, you can see here, you have a repeating sequence, you have a sine. You are going to intersect this 2 with an help of relation operator. Whenever which is greater, you are trying to going to generate. So now if you run it, I have told no, it will just take some time for compiling. Yeah, simulation is over. Now if you see in this graph, so I will just maximize and show you so that you will understand. So what, see here, it is here at with minimum thickness, gradually this thickness increases. Can you see it? Even I will zoom it some more further so that you can. So see how you are getting output. So whenever this is lesser than this, you are getting output. This gradually, this is going on increasing. So you can see in my pulse width also, the width is gradually increasing. Once it reaches, again it starts. Yeah, I will put auto scale. So you can see here, once it reaches here, you will get maximum width. Again the width starts decreasing, and this is for generating for positive half cycle. So no pulse should be there in the negative half cycle. And similarly, when you see, when you try to attach this for your negative half cycle, so if you attach this same way, go to mask, look under mask, and again if you connect this here, you will see for the negative half cycle. Okay, so this is the input ramp and this is your input sine. So you are going to compare the sine and ramp, and you have to see your how you are going to get waveform. So here just I am making it as axis 2. See, you will only gather some knowledge about Matlab, that's all. I think you will not be able to that much fast to simulate with me, because I have a vast experience and the only thing is time constraint. Okay, now if I run this, what should I get? I should get a pulse in negative half cycle, because you have positive half cycle and negative half cycle. One switch we have already seen for positive half cycle. So it will, positive half cycle will start from 0 to 0.01. Negative half cycle will start from 0.01 to 0.02, which is nothing but, we know that when you want 50 Hz, 50 Hz is nothing but 0 to 0.01 and 0.02. So 1 divided by 0.02, which is nothing but 50. So now what we have done is, I have generated pulse. So this generated pulse P1 and P2, you can see here P1 and P2 are the two pulses. This is positive pulse, this is negative pulse. So this two IGBT, this IGBT and this IGBT is going to work for positive half cycle. So you can see here I have connected P1 here, P1 here. This are it is not mandatory you have to connect with this and all. You just delete this, just drag from here, and also you can connect. Okay, similarly from the negative pulse I have given to the IGBT2 and IGBT3. So if I run now and if I see output across my load, I will get a AC output. So you can see here the output here the output is gradually increasing, reaches maximum and finally reaches to 0. This is for one cycle we are seeing. So let us see for more number of cycles. So I have just put it as 0.5. Again I am compiling and I am running it. Now I am going to see for more number of positive and negative cycles. Just I will stop and I will zoom it and I will show you so that you can see it clear. So if you want to see 2 cycles, so now you can see the output is like gradually the width increases, reaches maximum and again gradually it reduces. So this is how I am able to get sine waveform. So this sine waveform only I have shown in this PPT. So that is the output here, AC output. So your AC output, which is sinusoidal output, that can be given to your load. Whatever AC loads you want, you can give. So with this I will try to wind up. If you have any doubts, you can ask me, or you can feel free. Even I have a YouTube channel, so I will just post the link of my YouTube channel also. There also you can, even if you have any doubts or anything which you want to clarify in Matlab or any other subjects, even if you try to go and see in my YouTube channel, you can see about, you will have various content related to only academics. Okay, the channel itself is only for academics. I might have explained. If you have any doubts, you can ask me now. Just 1 minute, I will stop the record. So I have not taken so much of time because I have been asked that you have to travel back. That is the main constraint.